capacitor in an AC circuit. So what we see, we'll take a capacitor and a AC source. The capacitance of the capacitor is C. The AC source has a voltage, AC voltage V equal to V naught sine omega t. It has a frequency omega with which it is changing. Now, as the current goes through this, so there would be a voltage drop across this. This voltage drop, let's suppose this is VC, the voltage across the capacitor, right? So what we know is from our concept is Q, the amount of charge, divided by C, the capacitance, right? So as we already know, and we are assuming the charge that is moving or that is there in this capacitor for this particular source is Q, and then we can say that the voltage drop across the capacitor is VC, which is Q by C. Now, according to Kirchhoff's law, now we are applying the Kirchhoff's law and we need to find the current out. So when we apply the Kirchhoff's law, this voltage, that is the source voltage, and the voltage drop across here is the total voltage is same. So what we can write here, that V is equal to VC, right? Or we can write V naught sine omega t is Q by C. Also, now since we want to find the current, we can write current is d dt of Q, the way the charges are. So if I do the differentiation, time differentiation with a charge, I know what current would come. So that is what we are going to do. So as you take this here, therefore we get Q here. We can write V naught into C into d dt of sine omega t. That is what is going to give us the current I. If we do this, then we are going to get V naught C omega into cos omega t, right? But this is in cos term, and our general notion for the current, that is the AC current, should be always in sinusoidal. It's better to have in a sinusoidal notation changed. So this is V naught C omega. If I cos omega t, if I write it in sine omega t, then I have to write sine omega t plus pi by 2. That is what gives me cos omega t. So therefore I is what? V naught C omega sine omega t plus pi by 2. So if we are comparing this with, suppose, any other thing, then we can write that this I naught is actually V naught into C into omega, or we can write V naught divided by 1 by C omega. So as we have already told, this V naught divided by this part, this is what is the resistive element of that particular circuit. And here 1 by C omega or 1 by omega C, this particular quantity gives us the concept of what is the resistance that this capacitor is giving to this particular circuit. So if I naught is V naught by 1 by C omega, I can write it as a capacitance, the reactance given by the capacitor. So I can write it V naught by XC. As we have seen in the case of inductor, that was a XL, that is the reactance, and here this is the capacitive reactance. So this XC is 1 by omega C, or again if I just write omega as 2 pi nu into C. So what we see is this particular quantity is stopping the current. So this is adding a kind of resistive element, or this is kind of a resistance or hindrance for the current to flow. So that is what is being added up by the capacitor in the AC circuit, and very much this is depending on the frequency of the AC source. So if the frequency is high, then the reactance given is very low, and if the frequency is low, then definitely it adds up to a high reactance. So this is what we get. So first thing is that what we see, what is the capacitive reactance, and the SI unit for this is as well as this is same as the reactance, or sorry, resistance, that is ohm. So the capacitive reactance is what is the resistive element added to the circuit by the capacitor. Now let's see one more thing, the phase part. So this is the current that we are getting. The current, this current we are getting due to the source voltage. This source voltage is given, and from there the current is coming out. So what we see, the voltage here has only sine omega t part, but the current that is coming out, it has omega t plus pi by 2. It means that the current is leading and the voltage is lagging in this particular circuit. It means that, suppose if I try to draw a phasor diagram, it means if this is the voltage, this is V naught, this is omega t, then my I will be from the voltage V, and this is the current, from I in the 90-degree angle, this is pi by 2, omega t plus pi by 2 will be my current. So here in this case, the current is leading and the voltage is lagging behind. So this is what is the analysis of the capacitor element of the circuit.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.